Bayes theorem. Look at the definition. We have two types of probability. One is the prior probability. And this is initial probability value, original calculated before any additional information is obtained. Just what we covered in the previous session, like the basic probability, addition rule, or multiplication rule. This is all the prior probability. And the second type is the posterior probability. The posterior probability is the conditional probability that is assigned after relevant evidence or background is taken into account. And this is also called the Bayes theorem. And we can use the tree diagram to present the Bayes theorem, just like here. All these events must be disjoint. And Bayes theorem is one of the conditional probability. For example, we want to find the initial probability, and that is based on the given information of the subsequent event in here. Okay, so one more time. We want to find the initial probability given that using the subsequent information is obtained. So that will be the Bayes theorem. Okay, let's try this example. An economist believes that the economic growth, the probability of the stock goes up is 0.8. However, if the economic slowdown, then the probability of the stock goes down is 0.7. Assume there is 70% of chance that the economy goes up. So we try to present these questions using the tree diagram. Okay, and then first step, we're gonna let the variable in here. We're gonna let G represent the economic growth. X, that will be economic loss. U, that will be the stock goes up. D, that will be the stock goes down. Okay, so now let's try to use the tree diagram. So United States, either the economic growth or economic loss. And then for the last sentence here, assume there is 70% of chance that economy goes up. So we could write it down, the given information here, the P of G will be equal to 70%, okay, means like 0.7. And then since we only consider in the United States either economic growth or economic loss, so you could think about it, this is just like the complement. Okay, so we could find out what is a P of S in here. What's the probability that economics loss? We're gonna using the complement formula. Okay, 1 minus 0.7, that will be equal to 0.3. Okay, and then when the economic grow, the stock, it can goes up or the stock goes down. Okay, and then with the first sentence here, when the economic grows, probability of stock goes up is 0.8. Okay, we know that the stock goes up is going to be 0.8, but be careful. This is based on the given information that the economic grows. Okay, so this is going to be the conditional probability. Don't write P of U equal to 0.8. Okay, this is a conditional probability. We're gonna write it like this way. This is means probability that the stock goes up given that or under the situation that economic growth. That will be equal to 80%, which is like gonna be 0.8 in here. Okay, one more time. This is the conditional probability based on the economic growth and the stock goes up. And then we assume that either the stock goes up or the stock could be goes down. So these two guys is going to be the complement again. Okay, so we could figure out this guy that will be equal to 1 minus 0.8 here. But be careful, this is also the conditional probability. We're going to write it like this. Probability that the stock goes down under the situation that economic growth. That will be equal to 0.2. Okay, these two added up has to be equal to 1. Okay, if the situation is economic slows, then the stock is also, it can goes up or goes down, right? Goes up or goes down here. And then we have, if the economic slow down, then the probability of the stock goes down is 0.7. Okay, similar to the previous one here. This is conditional probability. We have the probability that the stock goes down is equal to 0.7 under the situation that economic slows. Okay, and then I want you guys try to figure out what is this one. Make sure you write it down as a conditional probability. Okay, you should have probability that the stock goes up given that economic slow. That will be equal to 0.3. Okay, so right now we just use the tree diagram to present all the question or information from here. Now let's try to answer the questions in here. Find the prior probability that the economics will slow. So they're talking about the probability that from here, okay, P of S. We just talk about it, that will be the complement of the economic growth. So subtract from 1 equal to 0.3. Okay, B, what is probability that economic grows and stock goes up? So we know to find the probability that first economic grows and then the stock is going to be goes up. So we're going to write it like this. Probability that economic grow and then stock goes up. So we'll be using the multiplication rule here. Remember the formula? Should be equal to that. And then we know about the probability of G already, right? That's a 0.7. And then this is the conditional probability. We got it in from here also. So plug it in. You're gonna get 0.56. Okay, C. What is probability of stock goes up? So stock goes up, we're looking for P of U in here, right? The thing about it, we do have a two situation that the stock goes up. Either economic growth and then the stock goes up, or economic slows and then the stock goes up. Okay, so we do have a two situation. First one, economic growth and stock goes up, or means like the addition, right? Addition rule. So P of S, economic slows and the stock goes up. Okay, and then we'll be using the multiplication rule again. So this guy will be exactly using the formula from the top here. And then this one, probability that the economic slows and stock goes up will be equal to this guy. Okay, now I want you guys to look at the tree diagram and plug in the information to see what you guys gonna get. Okay, check your work. You should get 0.65 here. Okay, last one. At the end of the year, the stocks went up. What is probability that the economy grows? Okay, this is the asking the Bayes theorem in here. We have the given information. Given information is at the end of the year, the stocks went up. The stock went up is talking about here. All right, this is the given information. And then use this given information to find the probability that economic grows. Okay, so that's the Bayes theorem. So try to work it out first. We are looking for probability that economy grows given that stocks went up. Okay, plug into the conditional probability. And again, this one, probability that the economy grow and stock goes up. We'll be using the multiplication rule again. And this one, P of U, that will be equal to this guy. All right, and then we get it from the part B and the part C here already. Okay, so that will be the Bayes theorem. Okay, you could also using the formula here. When you compare the formula, this is the Bayes theorem. Okay, using the formula. Here, this part, that's exactly same thing what we get it from here. Okay, that will be just like the formula. And then the method 3, we do have the iterative Bayes theorem. Okay, this is going to be method 3. And this method, you're going to assume some convenient value for the total of all items involved. Okay, you need to make up a number. Of course, you want to make up an easy number. And then you need to construct a table of rows and columns. Okay, construct a table with the rows and columns and then fill in all the information here. Okay, we're going to try the next example using like the method 3 here. Okay, example 2. Company manufacturing electronic components for home entertainment systems buys electrical connectors from 3 suppliers. It buys 26% of the connectors from supplier A, 31% from supplier B, and 43% from the supplier C. It finds that 1% of the connectors from the supplier A are defective, 2% of the connector from B is going to be defective, and 5% from the supplier C are defective. Okay, so now you know that we have the connectors, and these connectors made by 3 companies, company A, company B, and company C. And then the connector, it can be defective or not defective. So now I'm gonna create the table with 3 different companies, and for each company, the connectors can be defective or not defective. And then now you need to assume a convenient value. Okay, in this example, I will assume there are 10,000 connectors made by the company A, B, and C. Okay, so total has to be 10,000. And then using this information to fill in the table here. Okay, 26% of the connectors from the supplier A. Okay, so I will have a 10,000, the total number of the connectors times 26%. So you have 2,600. And then they say 1% of the connectors from the supplier A are defective. So from the supplier A, that will be defective. That's a 1%. So I use 2,600 times 1%, which is equal to 26. Now you need to think about it. If total connectors made by the company A is 2,600 and then 26 of them are defective, so how many of them is going to be not defective? You could subtract it, right? Right? The total number of the connector made by the company A minus 26 of them are defective, so you're going to get this number. Okay, now I want you guys use this information. Try to fill out this table. Okay, check your work. And then after that, find out the total number of the connectors are defective. So add it up here, the column 1 here. And then add it up here, find out total number of the connectors are not defective. Okay, double check, add it up, the total has to be equal to 10,000. Or here also, total has to be equal to 10,000. Okay, now we're gonna answer the questions here. If an electrical connector is randomly selected from the general population of all suppliers, find the probability that it was made by company A. Okay, so we are looking for the P of A. So made by the company A will be 2,600. And then out of the total number of the connector, which is 10,000. Okay, so that will be 0.26. And then find the probability that it is found to be defective. Okay, it has to be defective. Now look at the table. How many total number of the connectors are defective? That'll be 303, right? So we are looking for P of D. Okay, P of D. So P of D will be equal to 303 out of 10,000 for total. Okay, last one. If a customer buys one of these components and finds that the connector is defective, what is probability that it came from the supplier B? Okay, again, this is the Bayes theorem, conditional probability. We are looking for the probability that it came from supplier B, given that the connector is defective. Okay, connector is defective. So we're gonna write it down here. Probability that's made from the supplier B, given that the connector is defective. And then we're gonna plug into the conditional probability. Okay, so now here we are looking for the probability that made by the supplier B and defective. So made by the supplier B and defective. Okay, defective. So it's gonna be 62. And then what is the total number of the connector is defective? That'll be 303, right? So just plug it in. Then you're gonna get this answer. Okay, so now I talk about like the three methods. First one, using the tree diagram. Second one, straightforward using the formula. Number three, will be using the iterative Bayes theorem. Okay, just create the table and then make up convenient number. Okay, and try to make an easy number. If you try to make a number, and when you multiply like the percentage, you're gonna decimal, you may want to try to make another number. Okay, it will be easier. Okay, example 3. Similar example. I want you guys either using the method 1, method 2, or method 3. Okay, you don't have to know all of the method. You just pick one is easy for you. Okay, try it by yourself and you could try to work after that. I will show you guys the tree diagram method and also the iterative Bayes theorem method. Okay, first, you should create the tree diagram like this, made by three companies, company A, company B, and company C. And for each company, it can be defective or not defective. And then plug in the information here. Company A makes 80% of the ELTS in here. So P of A equal to 0.8. And then company B make 15% of that. So P of B equal to 0.15. And then the last one, company C, makes the other 5%. So P of C is going to be 0.05. And then made by the company A have a 4% weight of defect. Okay, this is conditional probability. Probability of the ELT is a defective, given that it made by company A. Okay, so you should have this guy. Defective, given that made by company A, equal to 0.04. And then this is going to be the complement, either defective or not defective. Okay, subtract from 1, you're going to get this guy. Second one, made by the company, the probability that the ELT is defective, given that made by the company B. Okay, and then complement again. You should get this one. Okay, company C, check your work here. Okay, so we're just using the tree diagram in here. And then answer the questions. So find the probability that it was made by the company A. We got it from here, P of A is equal to 0.8. Find the probability that it is found to be defective. Okay, found to be defective. So we do have a couple situations. Either it is defective, made by company A, or it is defective made by company B, or it is defective and made by company C. Okay, so what did line like this? Made by company A and defective, or, so additional rule, made by company B and defective, or made by company C and defective. And then for each of them, plug in the multiplication rule. And then plug in all this number here. Okay, and then see if a randomly select ELT is then test and is found to be defective. Find the probability that it was made by the company A. So this is the Bayes theorem, right? This is a conditional probability. We already know this ELT is defective. Okay, this is using the additional given information here. And then I want to find the initial probability, the probability that it was made by company A. Okay, probability of A, given that the ELT is defective. And this is A and D. You could get it from here, right? Probability A and D. So it should be this guy here. And the probability of defective, this here, these three numbers, I get it from here. You should get 0.703. Okay, this is how you guys using the tree diagram to answer the questions. And then if you try to use the iterative Bayes theorem, okay, that will be the same questions. And I assume the 10,000 ELT also. Okay, so calculate one by one. Check your work. Okay. And then answer the 3 questions. So find the probability that it was made by the company A. Company A is 8,000 out of 10,000. So that's 0.8. Find the probability that it is found to be defective. So the total number of the ELT a defective is going to be 455 and out of 10,000. C. If a randomly select ELT is then tested and is found to be defective, find the probability that it was made by the company A. So what the conditional probability? Probability A and D. So made by company A and defective, that will be 320. Probability of defective, so it's going to be out of 455. Okay, you're going to get the same answer when you're using the tree diagram.